Okay, so now that we have looked at our ANOVA and we've also looked at our contrast using the contrast command on sex and pines, where we found that there was in fact a difference between males and females at 4 pines, but at no other but not at 2 pines or at 4 pines. I now want to show you an alternative way of getting to this. Contrast works perfectly fine, but we can also use a PW compare. Now, this is not the same command that we used in tutorial 6. In tutorial 6, we use PW mean. And PW mean only works for one-way ANOVA. You need to use PW compare for two-way ANOVA. Now, the syntax looks a little bit scary, so let me walk you through what's happening here. We start off with PW compare. This is the main effect. This is the command itself. And then I have I.sex. I.sex simply means use all of sex. Use all of the gender. Use both level 0 and level 1. Compare that. At those who have 0 for pines. So those who have a score of 0 for pines. So it's only looking at those who had 0 for pines, and it's going to compare males and females. The brilliant thing about PW compare, which we don't actually get with contrast, is I can then also adjust it. So I can put in mCompare Tukey, because we have equal sample size, and last week we said that this was post hoc. There were no hypotheses. And then I can ask for my effects, and that'll give me my p-values and my t-statistics. So all that's happening is I'm using I.sex to say all levels of gender, and then 0.pines only at 0 pines. And then I can do the same thing at 2 pines, and then the same thing at 4 pines. So let's run this. Let's start at the top. Pairwise comparisons of marginal linear prediction. This simply means we're comparing means. Now there's a note here. Option Tukey ignored since there is only one comparison. That's interesting. I asked for a Tukey adjustment because of multiple comparisons, and this is telling me there's only one. This is a really interesting point because even though we have 3 tests, in this case we actually only have 2 groups that we're comparing together. And because we are only comparing 2 groups, so in this case males and females, there's no adjustment that's happening. Because we're not looking at males versus females at 0 pines and then males versus some other gendered group at 0 pines. It's only males and females at 0 pines. When we move to 2 pines and we look at males and females there, even though in terms of variable labels we're still talking about males and females, we're actually talking about a different 8 males and a different 8 females. Because it's now the 8 males that had 2 pines and the 8 males that had, the 8 females that had 2 pines. They're different to this. So even though these are, we're looking at gender 3 times, we're looking at 3 different subsets of the gender group. We're not looking at the same people multiple times. So technically this isn't multiple comparisons. So even though we've asked for Tukeys, Stat has told us, well, actually that's a silly idea because you've only got one group that you're comparing. So then if I look at this, what I see is that females and males at 0 pines don't differ. That's not surprising, we saw that before. And if we go up here, we get the exact same p-value, 0.177. And the same thing here, females and males, again, don't differ at 2 pines, and we get a p-value of 0.342, the same as what we had before. And then again down here, we're going to get the same p-value for females and males at 4 pines. Again, saying there's a significant difference. Same p-values up here. One of the benefits of this, though, is that it tells you the direction of the effect. Like, we can just look at the means and figure it out. But we can also get an indication of this. So here, what this contrast value is telling me is that there is 21.875 units of difference in attractiveness between females and males. I also know that this is telling me that females have the larger mean because it's females versus males, and this translates to the female's mean minus the male's mean. And so the only way that this score could be positive is if the females had a larger mean than the males. And we know this is true. We can tell that just by looking at the means table. But if I just want to know the direction of effect, I can look at this and say that there's a 21.875 unit difference in which females are higher than males.